Greetings, Algebra 2 students. This is Dr. Heron coming to you with the beginning of Unit 3, and we are starting to look at solving systems of equations. So what happens when you have multiple variables, multiple equations, and you're meant to solve them for one solution, one x value, one y value. So when we get into it, here's kind of what we're doing. Okay, so initial cost for Travis and his band to record. Their first CD was $1,500. Each CD will cost $4 to produce. If they sell their CDs for $10 each, how many must they sell before they make a profit? So the cost for CDs, so it costs them $1,500 straight up, no matter how many they sell, and then it costs them $4 per to make a CD. Okay, that's this line right here. So their income of CDs is just flat out $10 for the income of CD. If they sell 0 CDs, they make 0 money. So that's this line right here. So the $250 and $250 and $2,500, that is where they cross, okay? And that is the point where the band breaks even, okay? That is basically saying that is where they have sold enough CDs to start making money. Every CD after the 250th is going to be profit for them. So that means at 250 CDs, the band has made $2,500. So they have paid off their $1,500 debt, and they have made enough money to pay off every CD they've made. So that is after that is where they start making money. Okay, so a couple different ways to solve systems of equations: graphing, elimination, substitution. You've seen all these, and I'll add matrices to that because I'll show you how to do those, especially in class. If you have to watch this later and you miss it, come back and talk to me, and I will show you how to do that in a calculator. So you've got one solution, which is what happens most of the time. If the lines end up being parallel, or you end up with a mathematical truth, like you end up with just x equaling x or 7 equaling 7, that's going to be infinitely many. No solution is going to be a mathematical lie. So if you get something like 4 equals 7, that tells you that there's no solution. Okay, so if we look, 2x plus y equals 5, x minus y equals 1. So if I look, that's going to be y equals negative 2x plus 5. This one would be negative y equals negative x plus 1. Y equals x minus 1. So 2x plus 5 goes like this. So there's my first line. Y equals x minus 1 is here, so that's going to go straight up there. So where they cross is your solution. So my solution for this is going to be 2, 1. Okay, 2, 1. So for this one, if this becomes 4y equals negative 5x equals 7, or minus 7, plus 7. Sorry, I got there eventually. So then y equals negative 5/4 x plus 7/4. So 7/4 is going to be not quite 2. So down 5, 1, 2, 3, 4, 5 over 4. It's going to be right about there. So then the other one starts up here at 4, down 5 over 4 goes there. Those are never going to cross. Those are parallel. So that's going to be no solution. Okay, those just don't work. All right, so you need to be able to recognize when those are going to be parallel. And the dead giveaway is those are the exact same slope. So in graphing, standard form, converting here, basically solving for y, moving things around. Plot B, use the slope, and then you graph your points. So substitution, it works best when you have an x or a y by itself, like we have right here. So if I have x plus 2y equals 18, instead of the y, I'm going to put what y equals exactly in for x, or exactly in for y. Okay, so I'm going to have that. I'm substituting this whole thing in for y because it equals y. So that's going to be x minus 9 equals 18. So 2x minus 9 equals 18. So x equals, 2x equals 27. So x is going to equal, sorry, back that up. That's not 9. I don't know why I'm dividing. That was foolish of me. That should be 36. So that should be 36. When I add those, that is going to be 54. So then when I divide by 2, my answer is going to be 27. Okay, sorry about that. So now go back and substitute that in, and it doesn't matter where, and figure out what my answer is. Okay, so 27 times 1/2 is going to be 13.5 minus 18, so negative 4.5. So y equals that. So my final answer is going to be 27 and negative 4.5. Okay, so Matthew stopped for gas twice on a long car trip. Price of gas for the first station was $2.56 a gallon. Second station was $2.65. Matthew bought a total of 36.1 gallons of gas and spent $94. How many gallons of gas did Matt buy at each station, or at the first station? Okay, so there are two equations in here. So we'll call X the first gas station, call Y the second gas station. All right. Total of 36.1 gallons. So X plus Y equals 36.1. All right. The other one's the cost. So you went $2.56 for the first gallon, for the first station, then $2.65 for the second station. And all in all, you got $94. Okay. So the easy thing to do would probably be substitution, although if you could run it in a matrix, I would. So if you just ran it 1, 1, 36.1, then you wrote 2.56, 2.65, and 94, and solve that one, then you could do that. Well, actually, it would look more like this. There shouldn't be a line there. You're not dividing. So then if I inverse this and take it over, it becomes my answer. But we'll solve it the hard way. So y equals negative x plus 36x.1. So now substitute that. So 2.56x plus 2.65, but instead of y, negative x plus 36.1 equals 94. So now do some calculator mashing. So 2.56x plus 2.65x, it actually becomes negative, plus 95.665 equals 94. So then if I subtract this, I get negative 1.665, and subtract this, so 2.56 minus 2.65 is going to be negative 0.09x. So negative 1.665 divided by negative 0.09 is going to be 18.5. All right, so if it's 18.5, that's how much was bought at the first station. I'm done, okay? If I wanted to figure out how much was bought at the second station, I would take 36.1, subtract 18.5, and that would give me that answer. Now, elimination works best. Works best if you have same number in front of a letter and opposite signs, okay? Or at least opposite signs in front of the same letter. So here, I've got plus 2y minus 2y, so I'm just gonna straight up add those. 6x, this becomes 0y, so it's not there anymore. And that's gonna become 24. So 6x equals 24, so x is just gonna equal 4. So then if I go back and substitute that, 2 times 4 minus 2y equals 9. So 8 minus 2y equals 9. So negative 2y equals 1. Y is going to be negative 1/2. All right? 1 on the right side, you're not going to line up. You're not going to have it lined up perfectly right away. But you see how I have this one by itself, basically? I'm going to multiply this whole thing by negative 4. All right? So I'm going to keep the top one the same. The bottom one, I'm going to multiply everything by a negative 4. So I can get negative 4y, positive 4y. So that becomes negative 10x. That becomes 70. So x is going to be negative 10. Nope, x is going to be divided by negative 10. Sorry, got ahead of myself. Divide by negative 10. So x will equal negative 7. So then substitute that back in. All right, substitute that back in. I'm going to want 3 times negative 7 minus y equals negative 24. So negative 21 minus y equals negative 24. Add 21, add 21. Negative y equals negative 3. Y equals 3. There's my answer. All right, last one. Sammy purchased a basketball and a volleyball that cost a total of $67, not including tax. The price of the basketball is more than twice the cost of the volleyball. What was the price of each ball? So, total, if we go, basketball plus volleyball was $67. All right. The basketball is $4 more than twice the cost of the volleyball. So double the volleyball, add 4. That was the price of your basketball. Okay, so this one's set up for elimination. Okay, so if I go 2v plus 4 plus v equals 67. Okay, all I did was take this and throw it in for here. So 3v plus 4 equals 67. So 3v equals 63. So the volleyball is going to be $21. And then when I substitute that back in, so 2 times 21 plus 4, so 42 plus 4 is 46. That's how much the basketball cost. So that's how I do systems of equations. If you want me to show you how to do it on the calculator to help you, please let me know.